The normal distribution, also known as the Gaussian distribution or the bell curve, is simply a continuous probability distribution which is asymmetric. It is bell-shaped and it's widely used in statistics under probability theory. So it has the following properties. Number one, we must understand the asymmetry attached to normal distribution, that the left side mirrors the right side. So the mean, the mode, the median are all the same. They're equal at the center. Number two, the property is that it is bell-shaped. You know how the bell-shaped? The bell shape looks like this. We say it is asymmetric, meaning the left side mirrors the right side. It's bell-shaped. The area under the graph is equal to 1. Are we together? So you need to know the characteristics. Then it is unimodal, meaning it has a single peak. It's not like this. Then it upholds the empirical rule. The normal distribution follows the empirical rule, which is known as the 68, 95, and 9.5. According to this rule, the rule simply states that we have one standard deviation. So one standard deviation is equivalent to 68%. Two standard deviations are equal to what? 95%, and three standard deviations are equal to 99.5. So it follows the empirical rule. Now, under the empirical rule, confidence interval given by mu plus minus Z. So with that being said, we'll go into questions to do with the distribution. So Z is given by mu over standard deviation. So there are three steps that we need to follow. Number one, we need to illustrate. Number two, we need to shade. Number three, we need to standardize. And number four, we need to apply. So we're going to look at a question. For instance, if we're given an example where they have a mean of 300, and we are given a standard deviation of 25, and we are told that this is a normal distribution. We are asked to find probability greater than 350, for instance. So using the three steps there, we're going to illustrate. Our mean is 300 here, and our 350 is there. So greater means you're shading to the right. It's a shading here. So Z is equal to X minus mu over standard deviation. So 350, we subtract the 300. Here we divide by 25. We're going to get 50 over 25. This is equal to 2. So we said the mean is at the center at 0. So this means this is a 2 here. So according to our rules, whenever the shading is small, we subtract from what? From 1. So we read this from the table. 0.9772 is the reading if we go into the table. What is the reading at 2? let's open our statistical tables. Open our statistical tables, we check at 2.0, we're going to find 0.9772. So since the region that we're looking at is small, our probability of Z greater than 2 will be 1 minus 0.9772. What is the difference when we subtract? Zero point 0.0228. So activity 3, when you look at the question that we had, we are told that the lifetime of electronic devices has a mean of 300 hours. Standard deviation is 25. So you give your mu 300, standard deviation is 25. Then we are told to find the probability that the devices will last more than 350. So this is what I was doing. More than 350 is greater than 350. So the 350 is on the right side. If it's 250, we'll have put it on the left side here, meaning we're going to get a negative Z. So standardize this 350, which is a 2. And when we check this from inside the table, we're going to get the reading for 2, which is 0.9772. When we subtract from 1, we get 0.0228. So this is how this question is supposed to be solved. Then what percentage will lie between 300 hours or less? So what we do here, 300 hours or less. So we're going to illustrate. Then here we have our 300. Then they're saying 300 or less. So look at this area here. When we standardize 300 minus 300, it'll be at 0. When you read the 0 from the statistical table, 0 will simply take you at what? 50%. So what percentage would be 300 or less? This is already 50%. So this one is a walkover. So that's where the 50% is coming from. So it's required 0.5 times 100, so it's 50%. How about between 220 and 350? Check in my notes on my videos. I mentioned to you that whenever we have an interval, there's a treatment. So 300 here, we have 2 at 20. And the other one is what? 360. So if you're using the tables directly, you standardize. This is at 0, 220 minus 300. Then you divide by the standard deviation, which was 25. So 20 over 25, you get negative 3.2 here. And this side, 360 minus 300 over, you get 2.4. So you read in the table, negative 3.2, you're going to get 0.0064. Then if you're going to read the 2.4, we're going to get 0.99180. So if the two intervals just subtract the bigger minus the smaller probability. So that is what we got here. Subtract the bigger probability minus smaller probability, you get 0.9911. That is how we tackle intervals, whether they're on the left or on the right. If you're using the negative table, just get the figures themselves and get the difference between those two. Question 2, we are given a mean life of a certain cutting tool. The mu is what? 41.5. Standard deviation is what? 2.5. So what is the probability that a simple random sample, n is 50, will have between 40.5 and 42 hours? So to start with, we need to identify the case you're working with. Our mean is 41.5. Then here we have 40.5. And here we have what? 42. It's no different from the case we've been discussing. So here we standardize, this one is already at 0. So 40.5 minus 41.5 divided by standard deviation. We standardize this and standardize that. So what are you getting here when you standardize these two? So when you standardize that, the 40.5 will give you negative 2.83. You round off to the nearest 2 decimal places. Then you standardize the 42, we're going to get 1.41. So read these ones individually from the table as they are, the negative table and the positive table. So we're going to get, for this part, the probability, and for this part, the probability that you're going to get. So you subtract them, and the difference is going to give you 0.9184. That is the interval for the normal distribution.
But on that one, I've tried, and even somebody else as well called me on that one. We are not finding 0.9184.
Unless the doc made a mistake, but the concept is what you should carry on to say the figure that you get here and the figure that you get there. You read them directly as they are, then subtract them. So obviously here you're going to get a bigger probability. What are you getting? 1.4, 1.41. What are you getting? Can you read the statistics?
Okay, just a minute.
Yeah, that should read.
Collins.
Yes, please.
Yes, while he's checking, also mention that this question and the previous one are almost the same, but we didn't find the, what do you call this again, the standard deviation, the one where we're saying the square root. So maybe just make mention that when it doesn't say sample, you don't go ahead and start squaring and find the standard deviation.
Oh, okay. That's very important because here we've been given our standard deviation, which was drawn from this sample. So we needed to calculate the standard error. So
okay,
our standard error is given by standard deviation over sample size of n. So whenever we're given this, the probability that a sample of 450 is drawn. So here first we calculate or recalculate this standard deviation. So here we're going to say 2.5 over square root of 50. So the deviation that we're using in this case, whenever we're given a sample size, actually affects the formula of our z. Z in this case becomes x minus mu over standard deviation root of n. That's why this is the sampling error that I'm talking about.
Okay, it's clear.
So That's the only difference with the previous one. Sampling error here will be calculated. We're going to get 0.3526. So don't choose 2.5 here because your answers will be different. Then when you read the table readings from this one and that one, he's human, could have made a mistake, but the concept is, I've taught you, the concept is simply the same. All right, together?
All right. Thank you.
All right. Shilwa, are we on the same page?
Yes.
All right, so any other thing that you need clarity over?
So the negative 2.828,
You
is it
round it
okay
up
to
to
round?
two decimal places because you can't read it as it is.
So it will be negative 2.83, isn't
Yes,
it?
yes.
Okay.
All right.